Let's take a look at some examples that make use of the derivative of the natural log function. In this example, let's differentiate the square root of the natural log of x. So let f of x equal to the square root of the natural log of x. And let's differentiate f of x. To start things off, note that this is a composition of two functions, the outermost function square root of x and the innermost function natural log of x. So f of x is the composition of square root of x with my natural log function. To differentiate this, I'll be using the chain rule. So using the chain rule, f prime of x is equal to, first of all, the derivative of my outermost function, the square root of x, is going to be 1 over 2 radical x. So I will have my 1 over 2 radical x, but instead of x, I'm going to use my original argument that I had in there, my natural log of x. And from the chain rule derivative, I'm going to multiply by the derivative of the natural log of x, and as we've seen, the derivative of the natural log of x is simply 1 over x. Done. In the next example, we're asked to differentiate the function f of x equal to log base 10 of 2 plus sine x. Again, this is us taking the derivative of the composition of two functions, because our function f of x can be thought of as the outermost function log base 10 of x composed with the function 2 plus sine of x. To differentiate, we'll use the chain rule. So f prime of x will first take the derivative of the outermost function, our purple log base 10 function. And we saw previously that that derivative was 1 over x, but in this case 1 over the argument, times the natural log of my base. In this case, my base being 10. My argument here is my original 2 plus sine x. And to cap things off, I'll take the chain rule derivative of 2 plus sine x and multiply it at the end. The derivative of 2 is 0. The derivative of sine x is cosine x. And that's it.